Time travel. Whenever you hear time travel, the first thing that comes to your mind is the time machine of Doraemon, the first time travel gadget that we have seen in our childhood. And then from here we are very interested to know more about time travel. Often we think what if would be like if we could have a time travel. It's interesting, right? But is it really possible? Let's see together. What is time travel? We all are traveling with time. As time is passing, we are also growing up, but with a constant rate. But can we travel to past or future? Let's see. A renowned scientist named Albert Einstein came up with an idea about how time works. And it's called theory of relativity. According to this theory, time and space are linked together. It tells that faster you travel, slower you experience the time. Examples to prove time travel. Whenever you flew in an airplane, you notice that the faster is the velocities of airplane, lesser will the time taken to reach a respective place. It's indeed an example of time travel. Another example of time travel is GPS satellites. Is it possible? Stephen Hawking's final book suggests time travel may one day be possible. If one made a research grant application to work on time travel, it would be dismissed immediately, writes the physicist Stephen Hawking in his posthumous book Brief Answers to the Big Questions. He was right. But he was also right that asking whether time travel is possible is a very serious question that can still be approached scientifically. 3 real and interesting stories. John Titor. Noah. Hakan Nordquist. 7 ways to time travel. Black hole, Tipler cylinder, rotating universe, wormholes, cosmic strings, speed of light, warp drive. Facts by scientists. As several respondents noted, we constantly travel through time just forward, and all at the same rate. But seriously, time travel is more than mere fantasy, as noted by Gary T. Horowitz, a professor of physics at the University of California at Santa Barbara. Perhaps surprisingly, this turns out to be a subtle question. It is not obviously ruled out by our current laws of nature. Recent investigations into this question have provided some evidence that the answer is no, but it has not yet been proven to be impossible. John L. Friedman of the physics department at the University of Wisconsin at Milwaukee has also given this subject a great deal of consideration. Special relativity implies that people or clocks at rest or not accelerating age more quickly than partners traveling on round trips in which one changes direction to return to one's partner. In the world's particle accelerators, this prediction is tested daily. Particles traveling in circles at nearly the speed of light decay more slowly than those at rest, and the decay time agrees with theory to the high precision of the measurements. A recent surprise is that one can circumvent the grandfather paradox, the idea that it is logically inconsistent for particle paths to loop back to earlier times, because, for example, a granddaughter could go back in time to do away with her grandfather. For several simple physical systems, solutions to the equations of physics exist for any starting condition. In these model systems, something always intervenes to prevent inconsistency analogous to murdering one's grandfather. Then why do there seem to be no time machines? 2 different answers are consistent with our knowledge. The first is simply that the classical theory has a much broader set of solutions than the correct theory of quantum gravity. It is not implausible that causal structure enters in a fundamental way in quantum gravity, and that classical spacetimes with time loops are spurious, in other words, that they do not approximate any states of the complete theory. A second possible answer is provided by recent results that go by the name chronology protection. One supposes that quantum gravity allows microscopic structures that violate causality, and one shows that the character of macroscopic matter forbids the existence of regions with macroscopically large time loops. To create a time machine would require negative energy, And quantum mechanics appears to allow only extremely small regions of negative energy. And the forces needed to create an ordinary sized region with time loops appear to be extremely large. Conclusion. Yes, time travel is indeed a real thing. But it's not quite what you've probably seen in movies. Under certain conditions, it is possible to experience time passing at a different rate than 1 second per second. And there are important reasons why we need to understand this real world form of time travel.